All right, let's go ahead and take a look at something called dimensional analysis here. Essentially, it's a technique to express a measurement in different units. So if I'm giving you meters, you should be able to figure out inches, centimeters, or kilometers. And the best way to do that, or at least the most consistent way that we're going to use that in this class, is to use something called dimensional analysis. It's a fancy word basically for unit conversions, switching from one unit to another. A couple of things that makes this dimensional analysis really effective is going to require us to know certain terms. For example, conversion factors. Conversion factors are basically fractions that represent a value of 1, where the numerator and the denominator are effectively the same value. So that means when you have a fraction, right, the number that's on top, the number that's on the bottom, if they're the same, or whatever information is contained in either spot, if they're the same, then they're effectively going to be equal to just 1, right? And so this example here is asking you to identify the two conversion factors for relating seconds and minutes. Well, I think it's safe to say that most of us should know that for every 1 minute, there is 60 seconds, right? Let's abbreviate that appropriately, 60s. And so this relationship, which we can write as an equation, can also be written as a conversion factor. So that's not quite the conversion factor yet. Instead, it would either be 1 minute over 60 seconds, right? Doesn't that look like effectively the same thing on top and bottom? So that's equal to 1. Or alternatively, it can be the other way around, 60 seconds over 1 minute. So these two are essentially the same value, right? Because they're 1. No matter if it's on top or on bottom, the 1 minute can go on top, 1 minute can go on the bottom. The important thing is that you have two different factors for any one relationship. Depending on the situation, we'll use the appropriate one. Conversion map, this is more of a conceptual idea to help you organize your thoughts. This is not something you have to do every time. Some of you may need this to help you start off these problems, but after a while you can kind of just leave this by the wayside and just go straight into doing the problems. So this is basically a strategy, how you strategize to convert from one unit to the next. So how many seconds are in 5.6 days? So for this one, seconds and to days is a little bit less obvious than what we know from seconds to minutes. So what I can do here is kind of have like essentially a little map, an organizational strategy here where I take, okay, seconds, I'm given 5.6 days, which I'll abbreviate with just D, and I eventually have to convert to seconds, right? So this is just a visual way to sort of see what's happening. This is my overall goal, from days to seconds. But instead of going straight from days to seconds, we can again sort of break the day down into maybe hours, right? So we know that relationship between days and hours, 24 hours in a day. And again, going from hours to seconds, some of us may know that number off the top of my head. I don't, so I'm going to go from hours instead now to minutes, where I know it's 60 minutes in an hour. And then finally, with 60 minutes, or excuse me, for minutes to seconds, I know that relationship where it's 60 seconds in a minute. So instead of trying to make this like a one-step path going from days to seconds, you might have to take a bit of a longer alternate route, but ultimately the goal is still the same, going from days to seconds. Now, so far we haven't actually done the calculations yet, and that's going to require something called a conversion bridge. So this conversion bridge is going to be effectively how we show that work of putting it all together. Now, this is a chart, or it looks like a chart anyway, where you have these lines that represent certain things. So anytime you see this line, so whatever numbers show up here and here, that's going to be a multiplication. Try to write that out. That's totally legible. Whereas anything that is on either side of this, right? So if a number here and a number here, that's going to be division. So the two numbers basically, wherever they are, they're going to divide and multiply based on the relationship across this line. Let's see how this is put into action in this one example here. So how many seconds are in 11.2 minutes? All right, so let's try this out. First of all, let's go and strategize a little bit. All right, so we're given minutes, we need to go to seconds. Thankfully, we had that process, that relationship already in our head. We know that the relationship that we saw earlier, for every 1 minute, it's 60 seconds, or for every 60 seconds, it's 1 minute. Nothing too new here. So we basically set this up to where I can go ahead and use my conversion bridge to make this conversion happen. I'm given 11.2 minutes. Right? So as a reminder, again, I'll write this up here. This position is always going to be your given quantity. So I'm given 11.2 minutes. Now I'm going to convert this into seconds, and to do so, I'm going to take a look at my conversion factors. I have two of them available to me. My goal here is to switch out of minutes and into seconds. And the best way to do that is to pick one of these two right here, one of these conversion factors exactly as they're written, and put them into this spot here. So I'm actually going to go ahead and write in the one that is most appropriate. The reason why this one is more appropriate than the one on the left is because in this example, I know that minutes right here will cancel off with minutes there. Why is that? Well, again, both of these minutes are on opposite sides of this horizontal line. So that means they're going to divide each other. Minutes divided by minutes, those are going to cancel off. Also, what helps is knowing that this unit remaining will be seconds, and that's exactly what we need. Right, so this is basically one giant fraction, and the seconds will be on top, which is exactly what we need. So then to finish it out, I go ahead and do some calculations where I take 11.2 and I multiply that by 60 and then divide it by 1. So 11.2 times 60 divided by 1. The result of this is 672 seconds. So a couple things. Remember that your units have to match exactly as they were from the original work. Seconds is on the top. It's a numerator. So that means this is also going to be a numerator, which is good because we do want this to be seconds and not something like per seconds. Additionally, we also want to keep in mind our significant figures. So don't forget that when we look at this 11.2, that is a given value. That one has 3 significant figures. 60 seconds, 1 minute. Well, initially, right, you might think 60 seconds might be 1 significant figure, 1 minute might be 1 significant figure, but don't forget, right, these are constants, these are defined, so really these have infinite and infinite significant figures. The family of calculations we're doing here are multiplication and division, and when you have multiplication and division, the rule states that your resulting answer, your final answer, must match the number with the fewest sig figs, in this case, 3 sig figs here from the 11.2. So this one also should have 3 significant figures. And as you see here, 672, that's 3 significant figures. So that is the correct final answer. Okay, that's basically conversion factors and how you apply that into conversion bridges to do dimensional analysis. Naturally, there are some that are a little bit more involved. For this one, how many grams are in 44 centigrams? Well, again, we're given centigrams. We're trying to go to grams. That's something we can do with one step because we're basically going to apply a prefix to help us make that happen. What's the relationship between centigrams and grams? Well, you can either write it as 1 gram is equivalent to 100 centigrams, or 100 centigrams is equivalent to 1 gram. Some of you might also go another route. Some of you prefer maybe saying for every 1 centigram, it's 0.01 gram, or again, upside down, 0.01 gram per 1 centigram. Either way, they're both acceptable because as long as the top and the bottom are equivalent, these are valid conversion factors which you can use. So to put this into action, 44 centigrams, we're going to apply the appropriate conversion factor, knowing that centigrams on top here. I probably want centigrams down here, so I'm basically going to use this guy right here and toss that in this position. So I get 100 centigrams for every 1 gram. And then at this point, I'm having the unit that I want on top. And the math here is pretty straightforward. 44 times 1 divided by 100, that's going to be 0.44 grams. And again, double checking your significant figures. This is 2 that's given to us. This is infinite and infinite because these are also defined relationships. So then the resulting value must also have 2 significant figures, which we have here, 0.44 grams. Talking about multi-step work here, this one's going to be a little bit more involved, right? So how many seconds are in 5.6 days? We kind of talked through this example earlier where we had the map and everything. But I'm going to go ahead and dive right in because 5.6 days, right? This one's, again, one that we can easily strategize. Days, I'm probably going to want to break down into hours. Now, again, if you want to write out each conversion factor ahead of time, sure. But I think most of us know this. I need to have days on the bottom, right? Because I want the day and day to cancel those units off. And then on the bottom, do 1 day for every 24 hours. I also know my next relationship, trying to get from hours, again, eventually to seconds. Well, for every 1 hour, that's 60 seconds. And then finally, 60 minutes. And then finally, right, going from 60 minutes, and minutes again going to seconds, we know that for every 1 minute, there are 60 seconds. So I can chain this all together without having to break them up into individual steps, which is kind of nice, right? It makes our work really easy because all I have to do now is, again, cancel off hours and hours, minutes and minutes can go, and what do you have left? You have seconds left, exactly the unit you need. Furthermore, this makes your work a little bit easier. So in your calculator, I basically just go through and multiply and divide everything as it is. I just do one giant step. So I do 5.6 times 24 divided by 1 times 60 divided by 1 times 60 divided by 1, and then make that into one easy calculation. So when you stick that in your calculator, you end up getting a value of 483840. All right, so all these again, I have to double check my significant figures. I'm given a value with 2 significant figures to start, 5.6 days. And all these other ones, well, there's 24 hours in one day. That's a defined one. That's a defined one. All these are infinite sig figs. So 2 versus infinity. 2 is going to be how I round my final answer. So I'm going to round it based on these first 2. So my resulting answer will be 48, and everything else is rounded off 0, 0, 0, 0. Alternatively, you can also write it as 4.8 times 10 to the 5th power. And of course, I left off these earlier, which is shame on me. Seconds. So either of these 2 answers are. Let's keep this party going with this next problem here. This is one that involves another multi-step problem. We have a cross-country race, typically 5 kilometers, and we're going to use dimensional analysis given that 1 inch is equal to 2.54 centimeters. Exactly. That's kind of a key word. How many miles are in a cross-country race? All right, so let's put this together. Kilometers, right? That's what we're given. We're trying to figure out how to get to miles. Unfortunately, I don't know that relationship directly. You could Google it, but that's not the information you're provided. You were given the information between inches and centimeters. Well, inches and centimeters, hopefully you're kind of connecting this, is that inches is more related to the mile side, right? Because inches are part of the imperial set of units, inches, feet, yards, versus centimeters, which is more related to the meters, SI units. And so centimeters is just some prefix away from kilometers. So what I can do is kind of strategize a little bit. I know kilometers, I can probably switch it from km to meters, and then from meters to centimeters or something like that. Now, some of you, again, can go directly from kilometers to centimeters. That's fine too, right? Just kind of go your own way here. The centimeters, then, I can switch that over to inches because that's given to me in the problem. Inches, I can probably go from inches to feet, and then maybe from feet to miles. Some of you may need to take that some other route to get that, but a lot of this information I think you should know. Now, in terms of how this is put together, it is going to be just like what we've done before. Just go ahead and start off with what you're given. 5 kilometers. And then let's go ahead and do some work. So when we do some kilometer stuff, this one, we go ahead and know that for every 1 kilometer, there is 1,000 meters. And then for every 1 meter, there's 100 centimeters. The relationship given to me in the problem is that for every 2.54 centimeters is 1 inch. Again, make sure you know you're canceling off units, sort of thinking ahead. So kilometers, kilometers, meters, meters, cm, cm. And then we go ahead and finish out inches. So for every 12 inches, there is 1 foot. For every 5,280 feet, there is 1 mile. All right, so we finally have the unit that we need, miles in the end, and then we can go ahead and do some work. Put this in your calculator, do some calculations, so on and so forth. As always, we do double check their significant figures. So everything, all these conversion factors here, these are all infinite significant figures, especially knowing that 1 inch and 2.54 centimeters are exactly that. Anytime you're given that exactly word, significant figures essentially boils down to just being infinite. And then you do some calculations. Your resulting answer is going to be, let's see, back to 3.106 something miles, right? Looking at our significant figures, 5, this is kind of a randomly given number. Let's just assume it's exact. So this technically would also be infinite. So we can honestly report as many as we like. To make it actually easier, let's just make this 1 significant figure, right? Everything else is infinite all the way across the board, infinite all the way across the board. Let's try that better. That's not any better. Let's do that. Then that means our final answer would probably have 1. So the best answer to provide here would be about 3 miles. All right. Finally, again, this is about significant figures and multi-step calculations. The numbers here, right? Let's make sure we're clear about the significant figures. Essentially, if you're all staying within the same family of calculations, don't round until the very end. Let's see how this works. We have 5.6 days. I'm going to switch that over to hours again. That's going to be 134.4 hours. So normally I would ask you to go ahead and round appropriately right here. Apply the significant figures rules. But really, again, if you're someone who likes doing this intermediate step, right, instead of doing all as one giant long chain, keep a few guard digits and basically keep them all, right? So keep all of this 134.4 hours and toss them into the next step here, right? So don't do any rounding just yet. The reason is if you do some rounding right here, you actually end up losing some sort of numbers, and it's a little bit more complicated than what I want to get into, but you end up rounding with each calculation, so your final number is rounded away so far from what the original value is supposed to be. Gives you 80, 64. I'm sorry, I wrote the wrong number here. That should be minutes. minutes there. And then that one, again, like I said, we go ahead and carry this out. 864 minutes for every 1 minute, 60 seconds. And then we can round out this final. That ends up being 483840. But what I want to do is I want to look back at my original value. I have two significant figures here still, so I want to round this. So going back to my original answer, right, that's going to be 48 and then 0000 seconds as your final answer. Right, this is what you want. Just be clear about this, because if you do round with each individual step, right, that kind of change the number quite a bit. So this then end up being, and I'll do this in red to show that it's not what we want. Actually, let's do this in maybe perhaps green to show this is what we don't want. Maybe 130 right there. All right, and then 130 would go in here, and then you do this calculation. That would give you 7800 minutes. And then 7800 minutes, you'd stick into this position if you're rounding it incorrectly, and then you multiply that out. And your number here would end up being 468000, which is quite a bit different than the 4800 that it's supposed to be. So this green, please don't round in intermediate steps. Just basically keep everything, knowing that at the very end, you can do your significant figures rounding. All right, that'll do it.